role of satellites has become commonplace in our daily lives. We use them for communications, weather information, agricultural data. The feasibility of solar power satellites, chemical processing plants, and space stations is now being studied. Soon, the industrialization of space will begin. Leading business publications estimate that by the end of this century, total revenues from space-oriented business will have reached $30 billion. This access to space has created a new international competition among nations to provide economical transportation into Earth orbit for the commercialization of space. Already programs are underway in Europe and Japan, programs by governments and private industry. These foreign programs have one thing in common: the use of expendable launch vehicles, rockets that will be used once, then thrown away. But as the need for the routine access to space by the business, scientific, government, and defense communities becomes greater, the United States can no longer afford the luxury of the throwaway rocket. Our answer to this challenge is the Space Shuttle, the world's first reusable spacecraft, at home in the vacuum of space and the atmosphere of Earth. The solid rocket boosters will be jettisoned 2 minutes after liftoff and parachute to an ocean landing. They will be recovered and prepared for reuse. The shuttle will continue toward orbit powered by the main engines, which are fed by the external tank. Shortly before achieving orbit, the main engines will shut down and the external tank will be jettisoned. This metal shell will not be recovered, but will fall harmlessly into a remote ocean area. Powered by rocket engines, fed by onboard fuel tanks, the orbiter will continue into orbit. The astronaut flight crew consists of from 2 to 7 men and women. The most important function of the shuttle during its early missions will be the placement, retrieval, and servicing of satellites for the United States and foreign users. These satellites will be carried in the 65-foot long, 15-foot diameter payload bay, which has a capacity of 65,000 pounds. Up to 4 satellites can be deployed on each flight. This payload capability will greatly reduce the cost of each payload. To get some idea of the savings involved in terms of 1980 dollars, it costs about $22 million to put a single satellite into orbit on a Delta launch vehicle. The cost of putting that same satellite up on a shared shuttle mission is between $8 to $12 million, a savings of from $9 to $13 million. On some missions, payloads will be left in orbit for launch into deep space trajectories or into geosynchronous orbits. Geosynchronous orbits have an altitude of 23,000 miles. At this altitude, the satellite travels around the Earth at exactly the same speed at which the Earth is rotating, so that the satellite can remain over a given point on the Earth's surface. All communication satellites operate this way. In 1980 dollars, approximately $9 million per payload can be saved by using the Space Shuttle instead of expendable rockets to launch these kinds of payloads. Previously, any malfunctions of space probes or communications satellites launched on expendable rockets resulted in the complete loss of the payload. Now, using the shuttle, the payload can either be repaired on orbit or returned to Earth, thus saving hardware worth millions of dollars. Not only were satellites lost due to malfunctions, they were custom-made for specific missions and were not reusable. But because the Space Shuttle can retrieve orbiting satellites and return them to Earth, a new generation of satellites is now being built using replaceable, modular parts. The first of these cost-effective satellites is the multi-mission modular spacecraft. It can be used for 75% of the projected missions in the 1980s. Carried into orbit by the Shuttle, this mass production satellite can be adapted to a wide variety of missions by changing the modular packages on the basic structure. If any malfunctions occur, the part can be replaced by a space shuttle flight. This will add years to the life of satellites that would have become useless if they malfunctioned. The continued development and use of these modular satellites will greatly minimize future costs and result in further savings. The payload capacity of the Shuttle also allows for small, low-cost, self-contained experiment packages called Getaway Specials. These are experiments with minimum operating requirements for the flight crews, which will be flown on a space-available basis as conditions permit. The cost to fly these experiments on a $1980 base is from $6,000 to $19,000. Experimenters range from business and government agencies to individuals and educational institutions, including secondary schools. The Space Shuttle is about to enter its orbital flight test phase. Once this is completed, the Shuttle will begin operational missions. The users are standing by. Space in the payload bay has been reserved for the first 3 years of operation by the United States and foreign government agencies, by industry, by educational institutions, and by private individuals. Interest in buying this space has resulted in one of the most important accomplishments of the Shuttle planners, the capability to develop a firm pricing structure based on actual costs. This is of great benefit to the users of the Shuttle as well as to the operators of it. The flexibility and the reusability of the Space Shuttle will make access to the space environment economically feasible. During the first 2 decades of space flight, using expendable launch vehicles, the economic and technological fallout produced a quiet economic revolution on Earth. Space and space technology are assuming an ever more important role in our modern civilization. The instrument by which routine access to space will be achieved is the United States Space Shuttle.